In the time it took you to blink, roughly 15 separate computers, some of them possibly on other continents, just worked together so this video could load. You had no idea any of that happened. So what actually happens in the second between hitting enter and a page appearing? Almost nobody can actually explain it, including most people already working in IT. This isn't just theory. This is exactly what happens, step by step, on a real machine, every single time. Let's actually watch it happen. You will do this exact action. Type an address, hit enter, probably 50 times today. It's the single most repeated action in all of computing. And yet, if I stopped 100 people on the street, maybe 2 could tell me what actually happens in that gap. Here's why that matters. Every single concept in networking, addresses, routing, security, servers, all of it lives inside this one moment. If you understand this 5-second gap, you understand the shape of the entire internet. So, today, we're not going to wave our hands and say the internet does its thing. We're going to open it up. Here's the analogy we're going to carry through this whole video, so hold on to it. Imagine you want to send a letter to a friend, but you only know their name, not their address. First, you'd need to look their name up in a directory to get their actual street address. Then, that letter doesn't teleport to them. It travels through your local post office, then a regional sorting center, then possibly a national hub, then down through your friend's regional center, to their local post office, and finally to their door. Multiple independent systems, each one just passing your letter one step closer, using nothing but an address written on the envelope. That, almost exactly, is what your browser just did. The name was the website address. The directory is called DNS, and the postal system is the actual internet. In plain terms, here's the whole journey in 4 steps. 1. Your browser looks up the website's name in a giant distributed phone book to get its real address, a string of numbers called an IP address. 2. Your computer wraps up your request. Please send me this web page into a small package and sends it toward that address. 3. That package hops across multiple routers, like the sorting centers in our analogy, until it reaches the actual computer, the server, hosting that website. 4. The server sends the web page back the same way, and your browser assembles it into the page you see. Lookup, send, hop across the network, receive and build the page. That's the whole shape of it. Now let's open up what's actually inside each of those 4 steps. Step 1, the lookup. This system is called DNS, the domain name system. Your computer doesn't know the address yet, so it asks a nearby resolver. Think of it as the local directory assistant. That resolver, if it doesn't already know the answer, asks a chain of other directories until it finds the one authoritative answer. This website's real IP address is this exact string of numbers. That answer gets handed back to your browser, usually in a few milliseconds, and usually reused from a cache. So it doesn't have to be looked up every single time. Step 2. With the real address in hand, your computer needs to actually open a reliable connection, because the internet doesn't guarantee your data arrives in order or even arrives at all, unless something enforces that. That something is called TCP, and it opens the connection with a 3-step handshake. Your computer says, "Can we talk?" The server replies, "Yes," and "Can you confirm?" Your computer replies, "Confirmed." 3 messages, and now there's a reliable channel open between your machine and the server. that might be on the other side of the planet. If the site uses HTTPS, the lock icon you're used to seeing, there's one more handshake here, a security negotiation called TLS, where your browser and the server agree on an encryption method so that nobody in between can read or tamper with your request. This adds a little more back and forth, but it happens in milliseconds, and it's why that padlock icon actually means something. Step 3. Your actual request. Send me this page, technically an HTTP request, is sent as data broken into small chunks, and it physically travels across a chain of routers. Your home router, then your internet provider's network, then across major backbone connections, possibly across an ocean, until it reaches the network your target server lives on, and finally the server itself. Each router along the way only needs to know one thing. Which direction gets this one step closer, exactly like a sorting center that doesn't need to know your friend, just which truck to put the letter on next. Step 4. The server receives the request, does whatever work it needs to do, and sends an HTTP response back, the actual web page, images, and files, broken back into packets and routed back across the same kind of chain. Your browser receives all of that, reassembles it in the right order, and renders it into the page you actually see and click around on. All of that, start to finish, usually happens in under half a second. Let's watch the whole thing, start to finish, in one shot. Lookup, handshake. Hop, respond, render. Every website you've ever visited, every single time. Let's stop talking about it and actually see what this looks like. Here's a real lookup tool, recreated exactly, screen for screen. Type a website's address in, and there's the actual phone book lookup we just talked about, the resolved address, back in under a second. Now here's what a real connection capture looks like when you watch it. There's the SYN, there's the SYN, ACK, there's the ACK, the exact three-step handshake we just walked through, and there's the actual HTTP request going out, and the response coming back, packet by packet. And this is every single router a request like this passes through to get there. Each one of those lines is a real sorting center on the real internet. Here are the 3 things almost everyone gets wrong about this. 1. People think a website lives in the cloud as some vague floating thing. It doesn't. It lives on a specific physical computer, sitting in a specific building, somewhere on Earth, right now. 2. People think DNS happens every single time you visit a site. It usually doesn't, because the answer gets cached, which is exactly why a site can sometimes look broken right after its address changes until that cache clears. 3. And this one shows up constantly in interviews. People confuse the website's name with its actual address and can't explain that DNS is the thing connecting the two. Now you can. So, one more time, the whole shape of it. Your browser looks up the site's real address through DNS. It opens a reliable, secure connection through a TCP and TLS handshake. Your request physically travels across a chain of routers to reach the server. The server sends back the page, which travels the same way, and your browser puts it all together. 4 steps. Every website. Every time. Quick check before we go. Easy one. What system translates a website name into its real address? Medium one. What are the 3 steps of a TCP handshake in order? Challenge 1. Why might visiting the same website twice not trigger a new DNS lookup the second time? Drop your answers in the comments. I read every one, and I'll pin the best explanations. Here's your hands-on lab, and it takes 2 minutes. Open your terminal, Command prompt on Windows, terminal on Mac. Type NSLOOKUP, followed by any website's address, and hit enter. You'll see the real IP address your computer just looked up. Then try tracert on Windows or traceroute on Mac, followed by the same address, and watch the actual chain of routers your request hops through in real time. You are about to see on your own machine everything we just talked about. Do that lab. Screenshot your traceroute and drop it in the comments. I want to see how many hops your request took. This is video 1 of a real path through networking, built exactly like this. Real explanations, real demos, no hand-waving. If you want to keep building this understanding step by step, subscribe. Next video, we're answering the question everyone actually has. Why is your Wi-Fi slow? And it's probably not your router. And if you ever want a fully structured guided version of this entire path, there's a link below when you are ready. See you in the next one.